Okay, prove the following equations using principle of mathematical induction. 4 raised to 3 plus, or 4 raised to 4 plus, 4 raised to 5 plus, 4 raised to n is equals to 4 times 4 to the power of n minus 16 the whole over 3 for any integer n greater than or equal to 3. 1 times 3 plus 3 times 5 plus 5 times 7 plus 2 times n minus 1 times 2n plus 1 is equals to n into 4n squared plus 6n minus 1 is whole over 3, where n is an element of natural numbers. Now we'll prove these questions. Don't forget to subscribe, like, and share these channels. Now let us start from questions number 1. 4 to the power of 3 plus 4 to the power of 4 plus 4 to the power of 5 plus 4 to the power of n is equals to 4 into 4 to the power of n minus 16 the whole over 3 for an integer n greater than or equal to 3. Now, to prove this using principle of mathematical inductions, we follow the following steps. Step 1. For n is equals to 3, then we have 4 to the power of 3, which is the same as 4 times 4 to the power of 3 minus 16 the whole over 3. Simply replace n by 3. Then we have 4 to the power of 3, which is 16, and here 4 into 4 to the power of 3 minus 16 the whole over 3 means 4 to the power of 3 means 64. 64 times minus 1 6 means 48. Therefore 4 times 48 the whole over 3, which is 64. Therefore 64 is equal to 64, which is true for n is equals to 3. Step 2. Assume that it is true for n is equals to k. That is 4 to the power of 3 plus 4 to the power of 4 plus 4 to the power of 5 plus 4 to the power of k is equals to 4 times 4 to the power of k minus 16 the whole over 3. Step 3. We want to show that it is true for n is equals to k plus 1. Therefore, our claim becomes 4 to the power of 3 plus 4 to the power of 4 plus 4 to the power of 5 plus 4 to the power of k plus 4 to the power of k plus 1 is equals to 4 times 4 to the power of k plus 1 minus 16 the whole over 3. Now, starting from this left-hand side of our claim, we can prove. Therefore, now let us start from this left-hand side. That means 4 to the power of 3 plus 4 to the power of 4 plus 4 to the power of 5 plus 4 to the power of k plus 4 to the power of k plus 1. Now this statement here, 4 to the power of 3, 4 to the power of 4 plus 4 to the power of 5 plus 4 to the power of k is, from our assumptions, is 4 times 4 to the power of k minus 16 all over 3. Then we can add by 4 to the power of k plus 1. So this is equal with 4 times 4 to the power of 4 to the power of k minus 16 the whole over 3 plus this 4 to the power of k plus 1. Now let us rearrange, or let us simplify this. Now here we have this means this can be simplified as 4 into 4 to the power of k minus 16 plus 3 times 4 to the power of k plus 1 all over 3 by taking 3 as LCM. Then this is simplified into this. Again, this is equal with 4 times 4. Simply multiply this by 4. That means 4 times 4 to the power of k minus 4 times 16 plus, and here since 4 to the power of k plus 1 is 4 times 4 to the power of k, therefore 3 times 4 is 12, then 12 times 4 to the power of k the whole over 3. Now here here 4 times 4 to the power of k, and here we have plus 12 4 to the power of k. Therefore 4 times 4 to the power of k plus 12 times 4 to the power of k is 16 times 4 to the power of k, minus here 4 times 16. Therefore this 4 times 4 to the power of k plus 12 times 4 to the power of k is 16 plus 4 to the power of k minus 4 times 16 is all over 3. Again here we have a common 4. Now if we take common as 4, we have 4 times 4 into 4 times 4 to the power of k minus 16, because since 16 means 4 times 4, therefore 4 times 4 times 4 to the power of k minus 4 to the power of 16 is all over 3, means by taking 4 as a common, 4 into 4 times 4 to the power of k minus 16 is all over 3. Again, this using rule of exponential functions, 4 times 4 to the power of k is 4 to the power of k plus 1. So this is equal with 4 times 4 to the power of k plus 1 minus 16 is all over. This is the required result, which is the same as our claim. Therefore, this is the required result, and this is true for every n greater than or equal to 3. Therefore, it is proved. Question number 2. Question number 2 says that 1 times 3 plus 3 times 5 plus 5 times 7 plus 2n minus 1 times 2n plus 1 is equals to n into 4n squared plus 6n minus 1 is all over 3, for n is natural number. Now, to prove this using principle of mathematical inductions, we follow the following steps. Step 1. For n is equals to 1, since n is natural numbers, that means n starting from 1. So for n is equals to 1, we have 2 times 1 minus 1, the whole times 2 into, or 2 times 1 plus 1. And here, 2 times 1 is 2, then 2 minus 1 is, which is 1 times. Again, here we have 2 times 1 plus 1, 2 times 1 is 2, 2 plus 1 is 3, therefore we have 1 times 3. Again, here from the right hand side, n into 4n squared plus 6n minus 1 over 3. If n is 1, then we have 1 into, the whole 1 into 4 times 1 squared plus 6 times 1 minus 1 is the whole over 3. Again, here 1 squared is, which is 1. And the 6 times 1 is 6, and 4 times 1 is 4, therefore 4 plus 6, 10. 10 minus 1, 9. Is the whole over 3, therefore 9 over 3, which is 3. Therefore 3 is equal to 3, which is true. Step 2. Assume that it is true for n is equals to k. That means 1 times 3 plus 3 times 5 plus 5 times 7 plus 2k minus 1 times 2k plus 1 is equal to k into 4k squared plus 6k minus 1 is all over 3. Step 3. We want to show that it is true for n is equals to k plus 1. That means our claim becomes 1 times 3 plus 3 times 5 plus 5 times 7 plus 2k minus 1 times 2k plus 1 plus 2 into k plus 1 plus 2 into k plus 1 plus 1. That means plus 2k plus 1 times 2k plus 3 as equals to, our claim becomes k plus 1 the whole into 4 into k plus 1 the whole square plus 6 into k plus 1 minus 1 the whole 3. Now starting from the left hand side of this, and again this is simplified as, or this equations can be simplified as 4 times k cubed plus 18k squared plus 23k plus 9 the whole over 3, or this is the same as this is the first one. That means k plus 1 into 4 into k plus 1 the whole square plus 6 into k plus 1 minus 1 the whole over 3 is the same as, by simplifying this, the above, 4k cubed plus 18k squared plus 23k plus 9 the whole over 3. Now this is our claim. Now starting from the left hand side of our claim, or starting from this, Then if we show this or this, then it is proved. Now let us start from the left hand side of our claim. That means 1 times 3 plus 3 times 5 plus 5 times 7 plus 2k minus 1 times 2k plus 1 plus 2k plus 1 times 2k plus 3. Dear all, 2k plus 1 comes from here by substituting k by k plus 1. So 2 into k plus 1 minus 1, which is the same as 2k plus 2 minus 1, that means 2k plus 1. Again here by substituting k by k plus 1, then we have 2 into k plus 1 plus 1, that means 2k plus 2 plus 1, which is 2k plus 3. So the left hand side is here. So this is, again, this is the same as, since this statement up to here, 1 times 3 plus 3 times 5 plus 5 times 7 plus 2k minus 1 times 2k plus 1 from our assumption is, which is k times 4k squared plus 6k minus 1 all over 3. So we have, yeah, since this up to here is, or this statement, or this is, which is this, that means k into 4k squared plus 6k minus 1 all over 3, and plus is 2k plus 2k plus 1 times 2k plus 3. Again, by rearranging this and or by writing this, we have this, that means k into 4k squared plus 6k minus 1, and again here multiplying 2k plus 1 times 2k plus 3, then we have 3 into 2k plus 1 times 2k plus 3 all over 3. Again, this can be simplified as like this: 4k cubed plus 6k squared minus k plus 3 into 4k squared plus 8k plus 3 all over 3. Again, this can be simplified as by multiplying 3 and by adding like term. We have 4k cubed plus 18k squared plus 23k plus 9 all over 3, which is the required result, or which is the same as our claim, or the right hand side of our claim. So, which is proved. Therefore, thus it is true for an element of natural numbers. Dear all, if you subscribe it, don't forget to like it. Thanks for watching my video.